Good morning, students.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Uh, we are about to complete our syllabus. Let us quickly recapitulate what we have covered and what needs to be covered. I started with Unit 2 and we discussed register transfer micro operations. In that, register transfer language, register transfer, bus and memory transfers, arithmetic logic and shift micro operations, arithmetic logic shift unit. I hope you all remember all this. This
Yes,
topic,
ma'am.
yeah, very good. The other topic in Unit 2, basic computer organization and design. In this, we looked at instruction codes, computer registers, computer instructions, timing and control. Please try to recall the content for all these topics: instruction cycle, memory reference instruction, input output, and interrupt. Moving ahead, we started Unit 3, microprogrammed control. In this, control memory, address sequencing, microprogram example, design of control unit. All these topics were covered. Subsequently, CPU, Central Processing Unit chapter, including journal register organization, stack organization, instruction formats, addressing modes, data transfer and manipulation, and program control. These were the topics covered. Later, until last week, we were doing this computer arithmetic addition and subtraction algorithms, multiplication, division, and floating point arithmetic operations. All these were completed. Unit 2, Unit 3, totally completed. Then I started with Unit 5. From Unit 5, I have done pipeline processing, arithmetic pipeline, instruction pipeline, and RISC pipelines. A leftover topic for me is assessing and understanding performance, which includes CPU performance and its factors, evaluating performance. These are the topics that are left that I would be starting today. Meanwhile, let me tell you that uh, your exam, CA exam, is on 28th of April, online mode, same like before, objective type. The details will be discussed and communicated to you. Let's begin this assessing and understanding performance. Um, let's also look at the assignment questions. Unit 2, register transfer and micro operations have been completed. All of you have done, I hope. Computer organization design. Yeah, this also. From question number 18 until 45 are Unit 2 questions. Unit 3 has got 3 chapters. First chapter is microprogrammed control. These are the questions under it. Central processing unit. These are the questions. And you wrote, all of you have completed both the chapters as well as this third chapter. Last week I told you to do this hardware implementation of division algorithm. Have you all done it?
Yes, ma'am.
Yes, ma'am.
All right, very good. So Unit 2, Unit 3 completely you have got the notes. You have written all the answers to different questions. It's like you have created your own notes. It would help you for your exams. From Unit 5, these pipeline processing 108 until 112 has been done. And this week we will be studying this chapter and you will be doing these questions. Well, students, let us begin. No, this topic is not in the textbook. This topic, assessing and understanding performance, you don't find in your prescribed textbook, which is Morris Mano. So I have obtained it. Chapter, okay, assessing and understanding performance. This is one chapter in another textbook, which has been suggested for you, that second textbook. Before beginning the topic, will anyone tell me what do you mean by uh, performance? What do you mean by performance? And how do you assess your performance?
Carry out a work is considered as performance, ma'am.
What is considered? Please repeat.
Ma'am, carrying out a work or doing a work.
Mm, yes, carrying out a work or doing a work is your performance. And how do you measure your performance?
On the basis of time, quality of the work.
Efficiency.
Very good. Yeah, accuracy as well. Very nice, students. So here, what are we measuring? Whose performance? Am I measuring here any student performance or principal performance or someone else performance?
Computer performance.
CPU.
Yes, computer performance. And what is the primary component in a computer that performs all execution?
CPU.
CPU. CPU is the uh, a significant component of a computer that does all sorts of processing, including numerical calculations, textual processing, any data related processing, anything that involves any kind of computations or calculations or processing is done by CPU. CPU is central processing unit, or we can call processor. So processor performance we are going to study in this topic. This is the outline of this lecture. Defining performance. What is the meaning of performance? How do you define it? CPU performance and its factors. There are different factors as you were dif different measures you were talking about: accuracy, time, number of tasks completed, and so on. Various factors involved, various measurements are there. Evaluating performance, that's what metrics, and about the benchmark. What is the meaning of benchmark? This we will learn. What is the need of studying the performance? Uh, Again, question goes to you. Will anyone tell me what is the need of studying performance?
Ma'am, if we analyze our performance, in next, I mean, in future we can improve that. Similarly
Yes,
to CPU
yes,
also.
yes, very good. Performance analysis is very essential in order to make some kind of you know decisions, and as well as improvements. And when we talk about the performance of students, why do we measure the performance of students, and how do we measure? What is the means of measuring the performance of students?
Test and marks, ma'am.
Yes, test, mid exams, internal assessments, and semester end evaluations, semester end exams. Through that, the performance of students is studied in order to decide whether the student is promoted, passed, or failed, or have backlogs. Through that, certain aspects will be known about the studies of a student. Likewise, through performance, we will study the uh, CPU, activities, how CPU is doing, what CPU is doing, in how much time it is doing. Can we improve uh, its performance, or do we have to upgrade our CPU? If CPU is quite slow, you would like to upgrade it. How will you know? Based on the time it takes to do a certain task. Therefore, performance has to be studied. Performance of everything has to be studied. There are some conflicting goals. What are the conflicting goals with respect to user and vendor? User find the most suitable machine to get the job done at the lowest cost. User's goal is to get the best at the lowest cost. And here, application oriented metrics are involved. How much applications are being executed on that machine? Vendor persuade you to buy their machines regardless of your needs. When you go to buy a system, uh, you would have budget, first aspect. Second one, your requirement. Uh, Now, you might have seen I carried a notebook or a smaller laptop. My requirement was that I need to have a lighter weight this laptop. That was my requirement, and I had some 15K, 20K budget. Based on my requirement and my budget, I go out look for the uh, product. Whereas a vendor, the one who is selling, he tried to persuade me. He says that no, no, if you carry that smaller 10 or 11 inches laptop, it will, the font is very small, it will not suit your needs. You go for a bigger one, because if he sell bigger one, he might get more profit, for instance. Therefore, the goals of user and vendor conflict. Vendor thinks from his perspective of gain increasing the profit. User thinks of about having a machine with the lowest cost that performs or executes all his or her applications properly. And how to know the vocabulary and understand the issues. As a user or buyer, You make better purchasing decisions. As an engineer, you can make better hardware software design decisions. If you know the vocabulary and understand the issues. Why are we learning it? As a student, why you need to know about the CPU's performance and its various related aspects. Later on, you might be a user or a buyer of the machine or processor, and some of you might enter into software or hardware industry. When you move into the industry as an engineer, you would be designing new hardware or software, and you are making certain kind of decisions. Apparently, it is essential for you all to know about these things. It would help you uh, in both of your roles. As a user or buyer, when you go out, you can make good decisions while buying the machine. You may ask for 3 gigahertz processor or 5 gigahertz processor. If I talk about this 3 gigahertz or 5 gigahertz, you need to know the terminology, the vocabulary, and understand how 3 gigahertz operates and how 5 gigahertz perform. Essentially, all these things would be useful to you uh, when you buy or when you design. Performance of a CPU designer. In an attempt to quantify how well a particular computer can perform a user's applications. Users applications, what are our applications? When you are developing a code, you write a Java program to perform arithmetic operations. Say you are writing a program for stack or queue implementation in C language. Those are your applications. And quantify. What do you mean by quantifying? Quantifying is measuring how well a particular computer can perform. If you use the systems that are available in your lab, college lab, uh, as they are older systems, you might face a certain lagging or performance bottlenecks. Whereas if you have purchased good processors with high speed laptop and you execute the same program, you might feel that this one is better, it is doing fast. That is, you are attempting to quantify how well the computer is performing your task. You quantify with respect to time, uh, a lab computer or your own laptop, and you get to know, all right, this is better or that is better. What are the problems that are encountered? Essentially, it is software plus hardware issue. It includes both the aspects. It's not only about one particular software part or hardware part. It's both. Different machines have different strengths and weaknesses. You might have a machine with 4 GB RAM and quad core processor. Your friend might have octa core processor with 16 GB RAM. These are two different machines. They have their own strengths and weaknesses. Uh, if you talk about the strength of this second machine, it's having pretty good RAM capacity, and therefore you can execute larger programs. Here, the weakness of first machine is you cannot execute a very large program at once, and it need to be executed in parts as the memory uh, is much lesser than the second machine. So different machines have got different strengths and weaknesses. There is an enormous amount of hype and outright deception in the market. When you go to market, you have got lot of options available. You have different vendors providing different machines with different configurations. Key to understanding the underlying organizational motivation. What are the keys? Why is some hardware better than other for different programs? Will anyone tell me how hardware affects the program execution? Well, I gave an example just now. Hardware do affect the execution of programs. Hardware including processor, memory. These things contribute to the uh, faster or slower execution of programs. RAM is a hardware, processor is a hardware. If you have got 4 GB RAM and if your program is 7 GB long, uh, then the program would behave differently in the first machine, and the same program would behave differently in the second machine. And why this second machine is better? We can say because it has got more memory and it has got an advanced processor. Students, have you heard about GPU? And will you tell me the difference between CPU and GPU? CPU is central processing unit, the normal processor which you find in all the computer systems. GPU is graphical processing unit. GPU is uh, it was mainly designed to render graphics and for uh, playing games, high-end games. When you play games, there is a requirement to have a good graphics card with memory. If you have got more memory and the good graphics card, your game would turn out to be, uh, you know, uh, playing it in a amazing manner because it would be so clear and it would be so fast. Suppose if that game in the game there is some character that has to be moved. If the machine is slow, it will move very slowly with lags. If it is fast, it moves pretty fast. Therefore, here the idea is to have a good hardware in order to execute a complex program. What factors of system performance are hardware related? When system performance is measured, what are the other factors? Do we need a new machine or a new operating system? Both of these are related issues. Even operating system plays a vital role in system's performance. How does the machine's instruction affect performance? Please recall we learned CISC, RISC. Will anyone tell me the full forms of these? Well, this is a complex instruction set computer and reduced instruction set computer. We learned that CISC has got 200 instructions, whereas RISC has got up to 50 or 100 instructions. And how does that matter? When a system has got more instructions, does it affect its performance? And if it has got less instructions, does it have any impact on the performance? These are also the factors that need to be considered while evaluating the performance of the system. And why do we care about performance evaluation? With respect to purchasing perspective, it gives given a collection of machines, which one has the best performance, least cost, best performance cost. Best performance cost combination means it is giving executing more programs in lesser time, and its cost is less than other machine. This is with respect to purchasing. When a user is purchasing a new machine, uh, user would look for this. From designer's perspective, there are several design options available. Designer would like to um, design the hardware in such a manner that it can execute more programs in less time. Also, the cost of the chip that has been designed should cost low. Here also, it is with respect to performance and cost. If consider two companies X and Y. X company is giving good performance in less cost, and Y is giving good performance in more cost. It means that designer has failed in giving up in actually providing or designing a machine with good performance and less cost. Because all the users who are purchasing would prefer uh, X brand machine. It is in their best interest. Therefore, uh, designers should also try to create a design of chip, machine, hardware in such a manner that it should also satisfy the performance cost aspect. How to measure, report, and summarize performance? You have first performance has to be measured, report has to be generated, and it has to be summarized in order to understand, which is done through performance metric and benchmark. We will learn about this. What are the metrics and what is a benchmark? There is an example given here with respect to airplanes. Will anyone tell me here which one is better? Airplane, Boeing 777, Boeing 747, BSE, SUD, Concorde, Douglas, DC 850. These are four different airplanes. And different Uh, Here metrics are passenger capacity, cruising range means miles, cruising speed miles per hour, passenger throughput, that is number of passengers per miles, passengers into miles per hour, that is passenger throughput. How many passengers it is taking for that particular with that particular speed. Students, please tell me which one is the best? Which airplane is the best?
Ma'am, on on basis of which factor, ma'am?
Very good. Very good question. Um, what are the factors that are considered?
Here four, ma'am.
Very good. If I say passenger throughput, then which one is better?
Boeing 747.
Boeing 747. It is giving a good value compared to others. Yes, very good. You see here, it's number of passengers. Here, to obtain this, we require passenger capacity as well as miles per hour, both. For 470 passengers, it is achieving 16 speeds, which is higher than other airplanes. What metrics define performance? In this example, it can be capacity. If I say capacity, again Boeing 747 only would give better performance. Cruising range, speed, and when you talk about speed, taking one passenger from one point to another in the least time, transporting 450 passengers from one point to another. These are the factors, all right? With respect to speed, you are taking only one passenger from one point to another in the least possible time. Perhaps the vehicle moves faster if the passengers are low in number. And another aspect is transporting 450 passengers from one point to another. Uh, Apparently, this would take more time. When we talk about the speed depends on the number of performance. If it is uh, proportional, if speed is proportional to this, actually inversely proportional. If number of passengers increases, speed decreases, and number of passenger decreases, speed increases. In this scenario, uh, if speed has to be increased, then the vehicle, uh, not only airplane, I'm talking about any vehicle or any automobile, would prefer having less number of passengers. But then the cost would increase. When you are going in a cab and when you are going by a public transport bus, there's a lot of difference in the cost. But then uh, what what other factor is um low when compared to cost? Cost is low in bus, and also the time it takes is low. Here cab cost is high, the time to reach the destination is also high. Because it is cab, it will not stop at particular stops. Bus stops would be there. There are no such cab stations, cab stops. It is taking one passenger at a high speed in less time. But and the trade-off is that uh, passenger has to pay more, uh, price, more fare. bus, less fare, but then, you know, uh, it takes more time. These are the different aspects of performance, two notions of performance. With respect to computer, there are these two notions with which performance can be measured. Response time is the first one, throughput is the second one. We learned throughput. Where did we learn it and what is it? Will anyone tell me?
Ma'am, it's in pipeline parallel processing.
Very good.
The amount of processing done during in a given interval of time, then it's a throughput. Amount of work done.
Very good, Manas. It is the amount of work done in a particular time interval. That is throughput. Um, to increase the throughput, we resorted to pipelining, and then we looked at how arithmetic calculations can be done in parallel by using different registers, different computation units. Response time is also known as latency. It is how long does it take for the job to run, and how long does it take to execute a job. All right, and how long um, one must wait to get the response of a database query. It is nothing but the time to do a task. Response time is the time to do a particular task. That may involve running of a program, execution of a program, or execution of a query, database query. Throughput, how many jobs can the machine run at once? And what is the average execution rate? How much work is getting done? Total amount of work done in a given time. It is the definition of throughput. Response time is time to do the task, and throughput is the total amount of work done in a given time. The questions that need to be addressed here, well, the first one is we upgrade a machine with a new processor, what do we increase? Whether we are increasing the response time or the throughput when we go for a new processor. And
Throughput.
throughput, a new processor, throughput. Also response time? No?
Response
Okay,
time
response
decreases,
time
ma'am.
depends. Yes. No, it decreases. Why it is decreasing?
Ma'am, because we are using new processor, so we will
Mm-hmm.
carry out the work in a short time. So automatically response time will be decreasing now, ma'am.
Yeah. Right. Good. So response time decreases, throughput increases. The second question addresses, the second question asks, if we add a new machine to the lab, what do we increase? Yeah, will anyone tell me what do we increase if we add a new machine? There are two questions here. First one talks about having a machine with a processor existing. Later, this processor is upgraded. Upgraded means in place of this old processor, a newer, higher end processor is added to the system, which upgrades the system. This is machine upgradation. And when there are several machines, there are four machines. Now a fifth machine is added. What is the impact of this and what is the impact of this? Addition of a new machine or addition of, not addition, upgradation of a process. Yes, students. Okay, let me give you this question for reflection. Ponder over this and come up with the answer. And tomorrow, when I start the class, oh, all right, tomorrow I'll be taking your class because yesterday's class we missed. So tomorrow we'll be taking, I'll be taking at 9 a.m. All right, students. Tomorrow at 9 a.m., please ponder over this and think about various details of it. Give me the answer tomorrow for that. What is an execution time? Execution time is the elapsed time. Elapsed time is which counts everything, including the disk space, memory accesses, I/O, and so on. And it is a useful number, this elapsed time, but it is not good for comparison purposes. Why it is not good for comparison purpose? Because different machines would have different disks, different memory capacities, perhaps different I/O. If you are comparing, when you do it with the same machine, then this might be useful. Otherwise, this elapsed time means you are counting the time uh, required for all the tasks, including disk access, memory access, and I/O. CPU time, this would not count I/O or time spent running other programs. CPU time is one particular metric, elapsed time is another. Elapsed time includes, suppose you have started execution of a program, and then if if you prompt the user to a number, enter a number. Consider that user takes 1 minute of time to enter the number. Again, when you execute the same program, uh, another user, say another user executes the same program and he enters right away. Okay, within 1 second. This first user has taken 1 minute, second user has taken 1 second, entered 5. These two cannot be compared. Why these two cannot be compared? This I/O operations, user interactivity, all that differs. Some users would enter fast. There are some I/O devices which are faster. There are some I/O devices which are slower. So direct comparison cannot happen. So this elapsed time is not considered primarily uh, for the comparison. CPU time is the time. It can be broken up into system time and user time. User time, as I told you about this, that is user time. System time is the time the processor takes in order to execute, the time processor spends on the execution of the program, without counting this time which user is taking for its IO or any other task. And after splitting the time into system and user and measuring only the system time, that is the CPU time, would give us a better uh, metric. The focus is to measure the CPU time, the time spent executing the lines of code that are in our program. All right, the time spent for execution. Recall, when a line is executed, it follows that instruction cycle phases. Read, uh, fetch and decode, read the effective address, and then execute. For every line of code, the phases have to be executed, and that can be measured because that involves this CPU time. Means which involves CPU time, the last one, execution. The last phase in instruction cycle is execute the instruction. Fetch the instruction, decode the instruction, read the effective address, execute the instruction. This execute the instruction is relevant to CPU. Execution time on a computer typically divided into user time, system time, other time. User time, time spent executing instruction in the user code, time spent executing instruction in the kernel, other time. Other time is the time when the system is idle or executing other programs. When in Unix operating system is there in a system, time and top commands can be executed to check out uh, the elapsed time for IO, waiting, running for program, this user time, system time, other idle time. These various gray shades denote the time spent in user code, in uh, kernel mode, executing instructions, and other time when it is idle or doing some other execution. Here you can see this some 90.7 U. This is 12.9 S, 2.39. This is microsecond. This is second. Uh, and then this 90.7 plus 12.9 divided by this will give 65%, 1 by third of the elapsed time for IO, waiting, running other program. 65% uh, it is executing for it is using for execution. Therefore, if you divide from 100, if you see, if 60 means 35% left over, which is one third. One third of the elapsed time for IO waiting. All right, one third of the time it is spent in IO waiting. Performance expressed as time. Time is the measure of computer performance and is the only reliable one. Time is very reliable measure of computer performance. Performance of X is equal to 1 over execution time of X. Consider performance of some program X. It is 1 by execution time of X. If you calculate, then we'll get the performance. If the performance is bigger, it is better. And improve performance In other words, is equal to decreasing the execution time. If performance increases, execution time decreases. X is n times faster than y means performance of X over performance of Y is equal to execution time of Y over execution time of X. You see here, uh, it is inversely proportional. Okay, if one increases, another one decreases. That's why if you take performance of X over performance of Y, then it would be execution time of Y over execution time of X. Then X is n times faster than Y if it gives a value which is faster. Time measurement and clock cycles. Okay, these two, if we complete, then CPU time its factors we will study tomorrow. What does time means? It can be absolute time measure or difference between start and finish. Synonyms of this is running time, elapsed time, completion time, execution time, response time, latency. These are all um, synonyms to time. Time. They are not same. They are different, but then they encompasses uh, the time unit. Elapsed time includes memory, disk accesses, IO accesses, uh, and running time includes, if all are included, then the running time is the total time taken for a program to execute. You can just take execution time, which may not involve the disk and memory accesses. Everything response time uh, is the system performance, which includes disk access, memory access, IO, OS, CPU time. All are included. If you consider only CPU execution time or CPU time, or it implies CPU performance. CPU time is CPU performance. Response time is about system's performance, the whole of system's performance, including not only execution but other time as well. CPU time is only the execution time CPU spends for the task. User CPU time and system CPU time. Mm, these are absolute time measures. Relative time measures are normalized time measures. Running time normalized to some reference time in terms of clock cycles for computer designer. Uh, if you look at this, it is talking about the time it takes for a program to execute. Let us say 3 seconds. This is absolute time. Relative time means with respect to something else. You can say that you are executing a um, a project, a larger application, which takes 1 minute of time. In this 1 minute of time, it is taking 5 seconds to execute one particular segment of the code, one particular program of the application. Application involves several programs. This is with respect to something else, with reference to the application uh, execution time, which is 1 minute. This 5 second is not an absolute value. It is with reference to this relative time, the 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 time of application in which we have 5 seconds for one particular program. It's like this. Clock cycles. What do you mean by clock cycles? Well, instead of reporting execution time in seconds, we can use cycles. Seconds over program is equals to cycles by program into seconds by cycles. Clock ticks indicate when to start activities, which is an abstraction. Clock time is the time between ticks, seconds per cycle. Clock rate, which is frequency, cycles per second. 1 hertz is equal to 1 cycle per second. Clock time is the time between the ticks. Okay, 1 tick, 2 tick. What is the time? Uh, it can be seconds per cycle. If you consider 1 second, then the frequency specifies that cycles per second. How many cycles per second? 1 hertz, which is I just uh, told you about the CPU metric. If you say 2.5 gigahertz, can you tell me now how many cycles per second this processor can execute? Giga means, all right, tell me 2.5 kilohertz means how many cycles per second?
2.5 into 10 to the power 3.
Right, very good. Means 1000. If I say 2.5 megahertz, students?
6. 10 to the power 6.
Yes, very good. 10 to the power 6, which is 1 million. Not 1, 2.5 million um, cycles per second. If it is 2.5 gigahertz, if K is 1000, M is million, G is billion. 2.5 billion cycles per second. And here the calculation, a 200 megahertz clock has a 1 over 200 into 10 to the power of 6 mega. M is 10 to the power of 6. Kilo is 10 to the power of 3. Giga is 10 to the power of 9. Into 10 to the power of 9 equal to 9 nanoseconds cycle time. Means one instruction cycle will take 5 nanoseconds. Okay, in 5 nanoseconds, one instruction will be executed if it is 200 megahertz clock processor. All right, students, this one we will look at tomorrow.